today I'll be exploring Newton's 3 laws in 2 different scenarios. Kicking a ball and a ball hitting a man in the face. I chose to do 2 different scenarios in order to explain all 3 laws sufficiently and giving them all their fair share of explanation. First of all, we see that there's a ball at rest on the ground. Ball is there's 2 forces currently acting upon it. All other forces are not that significant. First of all, there's a gravitational force acting downwards on the ball, and there's a normal force acting upwards on the ball. So both forces are equal because the ball is at rest. Here we see the man's leg approaching, and right before it hits the ball is still at rest, but the man's leg is moving. Let's say the man's leg is moving at 2 meters per second. And let's say that the man's foot weighs 10 kilograms, and the ball weighs 5 kilograms. So what happens is, the force that is expressed by the man's foot is going to be 10 times 2. It's going to be 20 newtons. Because of laws of conservation of force, what happens is 20 newtons acting on the man's leg would be directly transferred to the ball. But the ball has a mass of 5 kilograms. So a force acting of 20 newtons on a 5 kilogram ball would have it moving at 4 meters per second. So we express the first law where the ball is at rest because of it standing at still, where an object at rest will stay at rest and is acted upon by an outside force, an unbalanced force, which is a man's leg. And because the ball is lighter, it's also expressed by Newton's second law, where because the ball is lighter, it's going to move faster. Because either way, it's the same force, but because the ball is lighter, it's going to move faster. The ball hits the man's leg. The man's leg hits the ball, and you can see there's some kind of recoil where here the ball hits the man hits the ball, then his leg warps a little bit. We see this because of Newton's third law, where every action has an equal and opposite. Every action force has an equal and opposite reaction force. Because the man is hitting the ball this way, there's a reaction force acting from the ball to the man's leg this way. So we see that the man's leg warps, kind of. If that wasn't true, what should happen is the man's leg shouldn't feel any force and would move constantly without any change of mass. Any change of force. The same 20 newtons of force will be acting on the man's leg. But because the ball is still at rest, there's a force acting on the man's leg. Then the man shoots the ball, and the ball is moving at a constant acceleration. So it accelerates from at rest, and then it begins to decelerate because the man's leg isn't accelerating the ball. So it moves at a constant velocity, which decreases over time because of wind resistance. This is the first situation. Our second situation is the ball hitting someone in the face. Here. So we see the ball the ball is moving at a constant velocity, or we can say it's constant velocity, but actually what happens is there's wind resistance acting on the ball, but it's so negligible, so we can ignore it. So what happens is the ball moves towards the man, and right before it hits here, the ball still has a force of 20 newtons. And let's say the man's head, it weighs the same thing as 10 kilograms. And the man's head is at rest. So what happens is, first law is an object at rest will stay at rest. So here the object is at rest. The man's head is still at rest because there's no force acted upon it. But right after the ball hits, the man's face starts to move. There's a force acting on the man's face. We see it with the motion of the entire face. Second law, which states that the ball, because it's lighter than the man's face, the ball will begin to decelerate quickly, faster, then the man's face will accelerate. Because the man's face is heavier, that means the same force applied on the same object will make the man's head accelerate slower while the ball accelerates faster. The third law states that every action has an equal and opposite reaction force. So what happens is, we can see that while the ball is moving, and then it begins to slow down. So here the ball, let's say it's moving at a constant velocity of 4 meters per second. It's moving constantly. Then as soon as it hits the man's face, it stops. And then it goes backwards. That's the reaction force from the man's face acting on the ball. Thank you, and that's all 3 laws expressed by 2 different situations. So let's revise one last time. Here, the ball's at rest, where there's 2 forces, the gravitational force and the normal force. Second law is, because the man's leg is heavier, the same force applied by the man's leg, which is required to move it, say, at 2 meters per second, will move the ball 4 meters per second because it's half the mass. Third law, where the man's leg begins to warp because of the reaction force from the ball. Second situation is, the man's face is at rest and the ball is at constant velocity, because an object in motion will stay in motion and an object at rest will stay at rest unless acted upon by an unbalanced force. Here, second law is, where the man's face is heavier than the ball, the man's face will decelerate slower than the man's face will accelerate slower than the ball decelerates. That means it requires more force to be applied to the man's face to accelerate it faster than the ball. For the same 10, 20 newtons acting on the ball will decelerate the ball 4 meters per second this way, but accelerate the man's head 2 meters per second this way. And we can see it in our animation. Here the ball decelerates quickly while the man's face accelerates slowly. Third law is, every action has an equal and opposite reaction force. Here we can see as the ball is moving at constant velocity, hits the man, and the man's face has a reaction force on the ball. Thank you.